Now, today's class, we are going to study what is this Archimedes principle and how it will be related to the buoyancy force. That is all we'll make it. Now, first of all of you remember a few days before when we are studying, we have observed the change in weight of an object or a change in mass of an object when it is keep on dipping into the liquid. Have you noticed it? If it is partially immersed, completely immersed, then the change in weight is taking place. Yes or no? Yes, guys. When it is measured, the weight of object is measured in air. The weight of the object is measured in water or any other liquid. Definitely, we are seeing the change in weight. Is it yes or no? That is what my question.
Yes, sir.
Yes, and we have been noticed that I told you that the weight which we are having in the air, we used to call it as real weight, and the weight which we are getting in water or liquid, we used to call it as what weight? Apparent weight. Is it yes or no? Means it is not the original weight, fake weight, we used to say that. Now, this apparent weight of an object is causing because of one force. What is that force? Anyone? Yes. It is called as because of upthrust, or we can say, what is the name of that force? We used to call it as buoyant force. So, if any kind of object with the help of spring balance we have been measured, do you remember or not, everyone? With the help of spring balance, if you are measuring a mass of an object in air or weight of an object in air, it will be always is the original or real weight. Now, the same object, if it is dipped in the water, partially or fully, definitely the expansion of the spring will be decreases here, the spring balance. So, you can see that the weight of the object is decreasing little bit compared to the real weight. So, that is because of one reason that the liquid is exerting always upward force on the object when it is immersed partially or what we can say completely. Okay, so now when the buoyancy force is greater, when the object is immersed partially or when the object is immersed completely? Anybody? Yes, please. When the buoyancy force is experienced more, when we experience it more, all of you should tell me. When we are partially immersed or when we are completely immersed? All of you.
Completely immersed.
Completely immersed. So, if the immersed portion of the body is increasing, then the buoyancy force experienced by the object is also increases. That is what we have seen in that activity. Is it as? You might be remember that image. It is there in our HN book also. Figure number 55. Experiment to study the magnitude of buoyancy force. Magnitude means amount of buoyancy force. You might be notice it. If the immersed portion of the body is increasing, then the mass or weight lost by the body is also increasing because the body will experience greater buoyancy force compared to when the object is immersed fully and compared to object immersed only partially. So if you notice it here, now a metal cylinder in air. So what is this weight called as? Real weight or apparent weight? Everybody. Real weight or apparent weight? All of you. Real weight. Now, if you go to the second image, now the second image, what they are saying, it is immersed how much? Partially it is immersed. If you notice partially, maybe it is 1/3 of the object is immersed. So, now the weight shown by this one is called as apparent weight or apparent mass. Now, what is the loss of mass from air to this one? 10 grams. Have you noticed it? Loss. Now, if the object is immersed 2/3, here 1/3 of the object, here 2/3 of the object, now here 3/3, fully it is. That is what 3/3 means, completely immersed. Completely immersed. Now if you will notice, from 1/3 to 2/3, loss of mass is how much, Abhirami? 20 grams. If it is fully immersed, what is the loss of mass from first to last? Check it, all of you. 30 grams. So that is what the statement you have to remember, all of you. If the immersed portion of the body increases, then the buoyancy force experienced by the body is also increases or decreases? Is also? Yes? Increases. Understand? So that is what you have to remember that. So now let us discuss this concept in mind. Now the same thing, only today's class we are going to study Archimedes principle. Okay, everybody. So now how to study this Archimedes principle? So observe a Greek scientist name called as Archimedes, who found that when an object is immersed in a liquid, it will experience a upthrust or buoyancy force. Do you understand, everybody? So that is invented by, who found by a scientist called as Archimedes. Now, remember, whenever any object is fall into that, for example, you are having one bucket of water. All of you tell me, one bucket of water is there, fully it is there, fully it is filled. Okay, guys, everybody. Now, let me take let me take for example, now Mithakshari will drop 10 grams of object. 10 grams of object. Fully it is there, Mithakshari. Now tell me, definitely some amount of water will fall down or not? Yes or no?
Yes, sir.
Yes, everybody? All of you? Now,
Yes.
instead of 10 grams, if I'll drop 100 grams object, now also water will be displaced or not? More amount of water will displace or not? Yes or no? Yes, all of you? And all that is what I'm saying. Remember, all of you, Archimedes found that when any object is immersed in a liquid, the object experience what force, guys? Object experiences what force? An upthrust force, upthrust or buoyancy force. And also object is doing what? Object is doing one thing. What is that? It will displace the liquid. Do you notice it or not? Everyone? Yes or no? Please respond.
Yes.
That is what you have to remember. So, and he also found that the weight of the object or body decreases when immersed in a liquid. So that is what we found in the activity also. The activity just which we discussed long back and which we discuss now. Archimedes only found that when any object is immersed in a liquid, it is experiencing the buoyancy force, first thing. Second one, the object is displacing the liquid. Displacing means what? Here, notice it, blue color. Here, water is still here only. Have you noticed it, everybody? Water is still here. Now, second beaker, water level is rises. Now, third beaker, water level is little rises. Fourth beaker, water level is rises or not? Everybody? Yes or no?
Yes.
So why the water level is rising? Or anybody is pouring? Or because of immersed body? Anyone? Why the water level is rising here? Mr. Arun, open your mouth, otherwise leave from the meeting. Why it is rising your water here? Anybody? Because of what reason? Because of immersed body. Do you understand it? Because of immersed body, the water is water displacing. Do you understand, everybody? So water displaces because of immersed portion of the body. And what is the third one? When the body is keep on immersing, the weight of the object is decreasing or increasing. Weight of the body. Weight of the body will
Decrease.
Decreases. So that is what it is. So that is only Archimedes has been found, and that is only called as Archimedes principle. Okay. Now let us come back to your general life, and you can see, for example, now let me take Mr. Arun Kailash is having 100 ml beaker. How much he is having, Amma?
100 ml beaker.
100 ml beaker. Now he filled the water, everything. As we know, 1 ml of water is equals to how many grams? 1 ml of water equals to, I taught you already, water alone it will be becoming special. What is that? 1 ml of water is equals to 1 gram. Same way, 1000 ml of water equals to how many grams? All of you, 1000 grams. That is what I said. 1 liter of water. 1 liter of water. Because as it is, water is the more standard one. 1 liter of water is equals to how many kg? Everybody, 1 kilogram. Understanding? Same way, 1 ml of water will occupy how much volume, Mitaksri? Volume I am asking. I taught you. 1 ml of water equals to 1 cubic centimeter. Same way. Understanding? 1000 ml of water is equals to how many cubic centimeter?
1000 cubic centimeter.
1000 cubic centimeter. Understanding? And if I'll take 1000 liters of water, which is equals to how many cubic meters?
1 cubic meter.
1 cubic meter. Everything I taught you very in detail. So remember that. Okay. Now, why I am teaching you this means, if you want to understand the Archimedes principle, you have to know this one. Now, Mr. Arun Kailash is having 100 ml of beaker, which is fully filled till end. Is it okay, Akilan? Understanding? Now, he dropped a stone, which is equals to, let me take a 50 grams. How much? What is the stone of that? Stone mass? Everybody? Yes, please.
50 grams.
50 grams. Now, when this stone is immersed inside, definitely the water will overflow and some amount of water will be fall down. Is it yes or no? Yes, please.
Yes.
Some water, I am saying liquid, consider as a liquid, guys, not water. Some liquid will displaces. Is it right or wrong? Everybody? So, if I measure, I want to collect this all, the water, whatever it is displacing, need to collect that water or liquid. If I measure mass of the liquid, displaces by whom, guys? Displaces by which body? Immersed body. Displaces by immersed body. Immersed body is equal to mass of the body. Is it okay? All of you? Any doubt? Please ask.
Sir,
Yeah.
he wrote 1000 liters is equal to 1 cubic meters.
Yes. Is it not right?
1 liter, right?
No, not 1 liter. 1000 liter. Do you want to prove it? I will prove it. You want Abhirami? Yes, check it. So you all people knows 1000 ml is equals to 1000 cubic centimeter. Is it right or wrong?
Yes,
Yes,
sir.
please. Now, basically, now how many liters for 1 cubic ml I will teach you. So observe. Basically, we know that 1 cubic meter is equals to 1 meter into 1 meter into 1 meter. Yes, Metakshri? So now,
Yes.
1 m equals to 100 centimeter. Tell me fastly. 1 m is equals to 100 centimeter. 1 meter is equals to 100 centimeter, which is equals to 10 lakh. Is it right or wrong? Cubic centimeter is equals to 1 cubic meter. Is it okay, ma?
Yes, sir.
Yes. Now, let us see now how we will write this one is. So observe very carefully. If you'll notice it, all of you, we want now in liters. So now 1000 ml is equals to 1 cubic meter. Do you understand, everybody? Means the sense of 1 liter is equals to how many cubic centimeters? 1 liter is equals to how many cubic centimeters? All of you. 1000 cubic centimeters.
1000.
Yes or no? So now with that same relations only we will say, now notice it, 1 cubic centimeter is equals to, it will come like a 1 by 1000, 1 by 10,000 cubic meter. This is what basically relationship between cubic meter and cubic centimeter. In this, any doubt, Metakshri and Abhirami, everybody? Are you clear?
Yes, sir.
If you have any doubt, please let me know. Now, let us discuss. Now we want relationship between 1 liter is equals to dash cubic meter. Okay. And same way, 1 cubic meter is equals to dash liter. Shall we start proving now? Okay, ma?
Yes.
Now, observe, we don't know what is the relationship between 1 liter and 1 cubic meter. Is it yes or no? Now, we know, check it everybody, we know 1 liter is equals to 1000 cubic centimeter. Is it right or wrong? Any doubt? Yes, please. Yes or no?
Yes, sir.
Now, see that. Can I write this one as 1000 into 1 cubic centimeter? Yes, Metakshri?
Yes, sir.
Now, in place of 1 cubic centimeter, I want meter cube. So, 1000 into 1 cubic centimeter means 1 by 10 lakh cubic meter. Is it right or wrong?
Yes, sir.
So, three zeros will get cancelled, which is equals to 1 by 1000 cubic meter is equals to how many liters?
1 liter.
1 liter. Now we want cubic meter. So 1000 is in division. Will come this side. Multiplication. So 1 cubic meter is equals to how many liters, guys?
1000 liter.
Are you clear now?
Yes, sir.
That is what. Any doubt? Anybody? Let me know. Agilan, understand, Agilan?
Yes, sir.
Derivating is very, very important. How we are doing is always matter. Mr. Aswin Balaji, do you understand or not? Yeah. Arun Kailas? Okay. So that is what it is. So anybody saying any doubt, ask me. Mitax, can you understand this? How
Yes, sir.
liters and cubic meter relation?
Yes, sir.
Okay. Now, what I'm saying, if Mr. Arun Kailas will dip 50 grams of object, now definitely some liquid will come out from the container. Now, if I measure the mass of that liquid which will come out from the container, definitely the weight of that liquid will be equals to the object which is immersed by Mr. Arun. That is what I am saying. Will you all understand what I am saying? Okay.
Yes, sir.
That is only called as Archimedes principle. All of you should remember the weight of the liquid displaced by immersed portion of the body, because body may partially immerse or may completely immerse, doesn't matter, which is equals to total weight of the object. That is what we used to call as Archimedes principle. Is it okay, guys? Yes? So, right.
Yes, sir.
Definition. When a body is partially, when Archimedes principle, very, very important. When a body is partially or fully immersed, in a liquid. Gokul, understand, Gokul? It will experience what? It will experience what force? I want to know. In a liquid, it experiences.
Brian.
Yes, it experiences. It experiences an upthrust, whose magnitude is depends on what, guys? Anybody can tell me? Whose magnitude? How it will be depends? Depends on the liquid displaced by the body. Are you understanding? Upthrust, whose magnitude is equal to the weight of the liquid displaced by the body. Is it okay, everybody? Yes, please. Now, I will teach you one thing. Remember, before we studied that weight of body is equals to in air is real weight, and when the same body is immersed in water, we used to call it as what? Apparent weight. Yes or no, guys? Or loss of weight. Is it okay, everybody? Please respond. Now,
Yes, sir.
whatever the loss we are observing from real weight to apparent weight, that is only called as upthrust. What we used to call, guys? Yes, please. We used to known as upthrust. So I will say upthrust is equals to weight of the liquid displaced. Is it okay, everybody? Weight in a loss in the weight of the body. Loss in the weight of the body. Or I will say loss, how I will get? Anybody can tell me? I will get loss by something, by subtracting something from somewhere. Anyone? Nitakshri? How I get loss? Weight of the body in where? Weight of the body in air minus weight of the body in where, guys?
Liquid, sir.
Okay, so that is what upthrust. So upthrust means loss in the weight of the body means weight of the body in air minus weight of the body in liquid. That is what we have to remember. Okay, guys? So I will get a loss in the weight of the body or upthrust is equals to, let me consider the weight of the body in air. The weight of the body in air is W1 minus weight of the body in liquid is W2. So that the loss in weight, which is equals to upthrust. So that is why I will say a body is lost its weight because of one force. What is that force, guys? What is that force? Buoyancy force, or what we used to say? Upthrust. So the loss in weight is because of whom, guys? Because of buoyant force. That is what you have to remember. Please note it down. Any doubt? Anyone? Clear? Ask me. Arun, understand, Arun? Okay, clear.
Yes, sir.
Any doubt, please let me know. If not, you can finish this one. So then we'll go to the next. So this is how the Archimedes principle will work. So remember, Archimedes principle means very simple. The buoyancy force acting on an object is equals to weight of the liquid displaced by the object. It may be immersed fully or maybe immersed what? Immersed what, guys? Partial.
Partial.
So whatever it is, suppose if it is immersed fully, some more liquid will displace. If immersed partially, some less liquid displace, but that doesn't matter, which is equals to upthrust. So that is the only called as, what we used to say? What we used to say? Archimedes principle. Are you understanding? Archimedes principle means you have to remember that upthrust is equals to weight of the liquid displaced. Understand that? Understand Mitakshri? Divya is not there. Yes. Abhinami. So that is what. So you remember Archimedes principle means you should remember upthrust exerting on a body is equals to weight of the liquid displaced by the object, immersed portion of the object. That's all it is called as Archimedes principle. Okay. Now we are having applications of Archimedes principle. Is very important concept. So many times they will ask you this Archimedes principle applications, which is there in our textbook also, but textbook it will be like a not point wise. So you can remember these are the 4 applications of Archimedes principle, which is necessary to learn also. So you all can learn this one directly. So the first application of Archimedes principle is Archimedes principle used in determining relative density of a substance, which we studied already. Relative density. What do you mean by relative density? Anybody? It is a ratio of what? Ratio of everybody. Density of a substance divided by anybody.
Density of water at 4 degrees Celsius.
Density of water at what temperature? 4 degrees
4
Celsius.
degrees.
Next, hydrometers. Remember the hydrometers which we are using for determining the density of liquids are based on Archimedes principle only. Okay, everybody? So that is why I said if density of a substance is greater, density of liquid is greater, buoyancy force is more or not? Yes, please. Buoyant force is also more. That is what it is. So what is the instrument we'll use to measure the liquid density? Everybody? Liquid densities. What is the instrument we'll use? Hydrometers. Please note it down. Next, lactometers. This is the most one we will use in our daily life. Lactometers. Quality of milk. Milk is purity or quality of milk is tested by a lactometer. So this lactometer also will work with the same principle, Archimedes principle, that is also based upon densities only. So lactometers are used for determining the purity of milk based upon Archimedes principle. These are the general things. One is relative density, second one is density of liquids, third one is purity of milk. Hydrometers, density, purity of milk, lactometers. Last one is most important one. That is what Archimedes principle is used in designing ships and submarines. So this is a major importance which we are having wide applications in our daily life, designing ships and as well as submarines. So please note it down, and all should know importance of or applications of Archimedes principle. Okay. So totally how many applications we have? 4. So 4 you should learn. So anybody is having any doubt, please kindly let me know. Okay. Clear? Understand, guys?
Yes, sir.
Now, this is what you have to remember. So this is how the relative density concepts and as well as Archimedes principle will work. So please write it all these applications. So by the time we'll start the next concept. Okay, write it fast, all of you. Anything doubt, please let me know, or else you can write it. So we'll continue with the next concept. So liquid density, hydrometer, milk purity, all of you should remember, milk purity will represent with lactometers. Completed? All of you? Okay, next. Complete, Amma, Mitakshree?
Yes, sir.
Okay. Now keep reading, all of you. An important property of buoyancy. All of you keep the same heading. An important property of buoyancy. An important property of buoyancy. An important property of buoyancy. Now, till now I am saying buoyancy, buoyancy, buoyancy. We can calculate it or not, buoyancy force? You tell me. Shall we calculate it or not? How much is the buoyancy? Yes or no? All of you?
Yes.
Yes, guys. So how much it is exactly? We can calculate it. So how to calculate it? That is what we are going to study now, formula. So now in front of you, totally four diagrams is there. Again, the same before the picture, what we studied, the same thing. First, object is immersed. You can see. Are understanding? Small thing. So next, little bit more. Next, fully immersed, but just below the surface. Now, it will be went deeper inside. Now you tell me, all of you, in which case the buoyancy force will be more? Anybody?
D.
Yes, everyone?
Last.
Yes, that is what. So observe in this all the four pictures, you can see object of volume V I have taken here. What is the volume of the object? All of you notice. What is the volume of the object here? Volume of the object. Volume of the object is V. Okay. Now, what is the volume of the liquid? You can immersed portion is you can see here. And immersed in a liquid of density D. The density of liquid is D. Now here, Archimedes principle will state that always the buoyancy force exerting on this body is equals to the weight of the volume of the liquid displaced. Is it true or not, everyone? Yes or no? Yes. So whatever the liquid is displaced by the immersed portion of the body is equals to total weight of the body. Do you understand, Mitakshree, Abhinami, Arun? Now,
Yes.
if you notice it, in this case, a body is experiencing little as it is submerged very less. So it is displacing more water, less water, more water, less water, water adjusted less. Now, if we take here, let us take the liquid displaced by the immersed portion of the water. I am considering as here what? What I am considering, guys? Little volume of water. What is that volume? V1. Do you understand, everybody? So which will be equals to the volume of the object inside the liquid. So the buoyancy force will also be very small in this case, as it is immersed portion is less. Now, second case, immersed portion is more. You can notice the immersed portion is more, so that now the liquid displaced is also more or less. More or less. Yes, please. Everybody, immersed portion is more or less.
More.
More. So that more volume of the liquid will displace or less volume of the liquid will displace?
More volume.
More volume of the liquid will displace. You can see here, before water level is still here. Now, water level touches to this point. Now, if the body is in below surface, see that the body is fully immersed. Now, the liquid displaces to till here. The body is went little deeper inside, already submerged fully. So that still the water level not changes. Have you noticed it? If it is under the surface or it is sinks fully also. Once it is fully immersed, The liquid level is not changing. Have you noticed it or not? Remains constant. Yes or no?